Okay. 2024 AP Stat exam. I have not looked at question 3 at all, so we're going to take a look at this and see if we can work through it. Give you my proposed solution, and we'll see how it scores after the reading goes. Number 3, a car maker produced 4 different models of cars, A, B, C, and D. A group of researchers investigating which model of car has the longest distance traveled per gallon of gas, the mileage. Higher mileage is considered better than lower mileage. The researchers will conduct a study in which they can contact several owners of each model of car and ask them to estimate their mileage. Is this an observational study or an experiment? Justify your answer in context. This is an observational study. Because the researchers are not assigning drivers randomly to treatment groups. I think that's sufficient. You could go on and explain more, but I think that would be sufficient. An experiment requires random assignment of treatment groups. Treatment groups here would be, I'm going to say such as different car models. I think before that last clause was sufficient, but we'll add a little context there by throwing the car models in. Model D has an autopilot feature in which the car controls its own motion with human supervision. James owns a Model D car and will investigate whether using the autopilot feature results in higher mileage than not using the autopilot. James will drive his car on 70 different days to and from work using the same route at the same time each day. James will record the mileage each day. James will use a completely randomized design to conduct his investigation. Describe an appropriate method James could use to randomly assign the two treatments: driving using the autopilot feature and driving without using the autopilot feature, to 35 days each. Okay. James could assign each workday a number. One, two, the number of days worked in a year. And I'm going to go inside a unique number. Then, using a random number generator, he could select 70 random numbers ignoring repeats from 1 to the number of work days. Renumber those. Renumber the selected work days. One to 70 from earliest to greatest. To latest. Then use a random number generator to randomly select 35 numbers from 1 to 70, ignoring repeats again. The selected numbers, 35 numbers, assigned to autopilot group, other, so days instead of numbers, work days, how about that? Other 35 work days assigned to no autopilot group. And I think that's sufficient for Part B. After the investigation was completed, James verified the conditions for inference were met, conducted a hypothesis test. He discovered a mean mileage when using the autopilot feature was significantly higher than the mean mileage when not using the autopilot feature. James is a member of Model D Club with thousands of members who all drive Model D cars. He will give a presentation to Model D Club members at a meeting later this year and would like to state the results of his hypothesis test apply to all Model D cars in his club. Another member of the club, who is a statistician, tells James his findings do not apply to all Model D cars in the club. What change would James need to make to his original study to be able to generalize to all Model D cars in the club? James could get a list of all Model D car members, Model D Club car members, and randomly select, well, randomly assign each of them a number, one to the number of members, you could use a random number generator. Randomly select 70 unique numbers from 1 to the number of members. Unique implies ignore repeats, but just to be safe, I'm going to say ignoring repeats. He could place the names of all 70 selected into a hat, shake the hat well, and randomly select 35 names. He could assign the selected to drive their cars on autopilot and the 35 not selected. To use the autopilot. Then each driver repeat the process. From Part B. That's all. That's enough. That should be enough. And this is number 3.